Dear students, greetings. Let's discuss the correction of the CAT of embedded systems software integration taught in year 2 at Rwanda Coding Academy. Let's start by section A. Section A is made up of multiple choice questions. It's made up of 20 questions, each awarded, its correct answer awarded half mark. Sub-question number 1. What's the primary function of the code editor in the Arduino IDE? Is it for uploading code to the microcontroller? No. The Arduino IDE doesn't do the code uploading. It's not its function. Remember, it's code editor. Debugging hardware errors? Not really. Writing and editing code? Yes, that's its job. Does it do any monitoring? No, that's not for the code editor. Code editor serves to write and edit code. So the answer is C. Sub-question number 2. How do you comment a single line in the code editor? By starting the line with hash? No, that's for Python and PHP, probably maybe other languages, but it's not for the code editor of Arduino IDE. By enclosing the line? No. By starting the line with slash slash? Yes. Yeah, it's not C. Okay. What does the serial monitor, that's question number 3, what does the serial monitor allow you to do? Compile the code, the serial monitor, send and receive data from the microcontroller, upload the bootloader, store code in flash memory. Serial monitor serves to send and receive data from the microcontroller. Remember, microcontroller is serially connected to the computer using UART protocol. Which is typically used by the serial monitor for Arduino Uno by default. That's question number 4. 4800, 600, sure, 600. These are the other boil rates, but the default one is 9600. Sub-question number 5. What does the verify button in the Arduino IDE do? This verify button serves to check the code for errors without uploading it. It's not uploading the code to the microcontroller. It's not about running the program on the microcontroller. It's not opening the serial monitor. It's about checking the code for errors without uploading it. When you hit the verify button, it will compile the code and return. It will run the code, and if there are errors, it will return them. So question number 6. What does the upload button in the Arduino IDE do? Upload. That's what it does. That's what it does. That's what it's said to do. Is it writing the code to the Arduino's ARM? Is it about sending the compiler code to the Arduino's flash memory? That's the correct answer. It sends the compiler code to the Arduino's flash memory. It's not displaying the output. It's not running the order. It's about sending. That's what the button upload. What file type does the Arduino compiler generate before uploading? It's not text. It's not the exe. Exe, it's packaged for Windows, and it's not .z. It's hexadecimal. Hex. Hexadecimal. As you know, we upload hexadecimal, and the bootloader will convert the hexadecimal to binary, and the binary code will be sent to the flash memory. As discussed earlier, the bootloader received the program, converted into binary, and writes it to the flash memory. Question number 8. If the Arduino IDE cannot find the correct component, what's most likely the issue? The Arduino IDE cannot find the correct component. Flash memory is full? No. USB cable is not connected properly? Yes. The loader is corrupted? No. The code has syntax errors? No. The Arduino IDE cannot find the correct component because USB cable is not connected properly, or sometimes the incorrect connection is due to broken cable. If the cable is broken somewhere, especially at the level of connectors, the IDE will not be able to find component. Okay, question number 9. Which menu in the Arduino IDE allows you to select the board and component? That's tools. It's not in the file. It's not in edit. It's not in the sketch. If you want to find the component, you start by tools in the menu of the IDE. Question number 10. What happens if the code contains an error during the verify process? Remember, question 5 I talked about verify button, and we found out that it checks the code for errors without uploading it. Now, you hit the verify button, errors were found, and what happens if the code contains an error during the verify process? The Arduino resets. The code is uploaded with warnings. No. The ID freezes. No. The code compiler shows error messages in the console. This is what happens. Okay, great. Let's go to the next page. And let's start from sub-question number 11. What's the role of USB cable in an Arduino setup? USB cable. What's the role? Powering the microcontroller and facilitating data transfer. Yes, it does both. It powers the microcontroller and it facilitates data transfer, both functions. B says, only powering the microcontroller? No, it does it, but it's not only. Only uploading the code? Not only uploading the code. Only running the serial monitor? Doesn't even does that. The answer is A. Powering the microcontroller, that's first, and second, facilitating the transfer. Sub-question number 12. What caused a USB cable to fail during the code uploading? Incorrect Arduino ID version? No. Syntax error in the code? No. Insufficient flash memory? Faulty cable or loose connections? Yes. If you're unable to upload, or if code uploading fails during code uploading, most probably the cable is loose or broken. Sub-question number 13. How can you determine if a USB cable supports data transfer? How can you? It's not easy to know. I mean, it's not complicated to know. You see this. Check this sign. Check out this sign. Check out this sign. When you buying a USB cable and you don't find this sign, most probably the USB cable you're buying is for powering only. A power USB cable has only two wires, one for plus and another for ground. I mean plus 5 volts, because in electricity, in DC current or a DC voltage is marked by plus and minus. Minus means ground, plus means the voltage level. In this USB case, that plus symbolizes 5 volts, because from a USB port we get 5 volts. Okay, so to determine if a USB cable supports data transfer, it's not related to checking the cable's length. You look for a data transfer label, the label I've just shown you, or test with another device before buying it. That's the answer. What's the function of the bootloader on the Arduino microcontroller? The function of bootloader, it's not compiling the code, it's not running the serial monitor, it's for uploading the program to the microcontroller's flash memory. It's not related to powering the USB cable. Uploading the programs, as we've seen, before uploading the code, it's converted to hexadecimal or X. The bootloader receives the code, the compiled code, into hexadecimal format and convert it into binary format before sending it or writing it to the flash memory where the program will be running as long as the microcontroller is powered. Sub-question number 15. What happens if the bootloader is missing or corrupted? That bootloader, we've just seen the function. What happens if it's missing or corrupted? The Arduino IDE cannot open. No, it will open. The serial monitor cannot display data. The serial monitor will display data. The microcontroller cannot receive new programs. This is what will happen because the role of bootloader, as we've seen, is receiving a program in hexadecimal, converting it into a binary, and writing it in the flash memory. So if it's corrupted or missing, this won't be. The microcontroller cannot receive new programs. What's stored in the flash memory of the microcontroller? Of course, temporary variables during execution of compiled programs uploaded from the IDE, of course. Number 17. How is the flash memory different from RAM in Arduino microcontroller? Flash memory is volatile, while RAM is non-volatile. That's not the case. RAM is used to store programs, while flash memory stores variables. No. RAM has a larger capacity than flash memory in microcontroller. No. Flash memory is used to store programs, while RAM stores temporary data during execution. Great! That's the correct answer. What could happen if the flash memory is full? The flash memory is full. Think of it. The bootloader is trying to push the received code, but the flash memory is already full because the program is larger, the bootloader cannot no longer send more code because yeah, the memory is already full. In that case, the Arduino IDE will crash. No, the code cannot be uploaded to the microcontroller. Of course. Yeah. Sub question number 20. No, now 15. No, number 19. Actually, sorry. Which component ensures that the Arduino starts executing the correct program after power up? Which component ensures that the Arduino starts executing the correct program after power up? Bootloader, no, bootloader is done already, long ago. Did its job receiving the program, converting it from hexadecimal to binary and sending it to the flash memory, then the ball in on the ground of flash memory. What's the maximum size of a program that can be stored in the flash memory of an Arduino Uno? The maximum size. That's too big, too small, too small. That's that too. We are done with section number A. Let's now move to the section number B. Section number B is made up of two questions. Question number 11 and question number 12. Each of them is marked with 10 marks. The total marks for section number B is 20 marks. Let's get started. Question number 11. Consider a joystick module connected to the Arduino Uno board and programmed using the Arduino IDE to control the character in the game running on the PC to which the Arduino Uno is connected. Complete the diagram by connecting the joystick pins to the appropriate pins of the Arduino Uno. Let's say let's connect the ground to one of these grounds here. With 5 volts, let's connect 5 volts to 5 volts here. And let's connect VRX to A0. And let's connect VRX to A1. Then let's connect the switch to digital pin 2. Okay. If you choose to make these connections, then the program in B will be completed as follows. VRX is connected to A0. So this will be A0. Joy Y pin, because you connect the VRY to A1, that will be A1. And switch button, that's 2. Now, to which pin mode shall we have for the switch pin or the bad pin? That's input, because we are reading the signal from it. Underscore pull up. Do you know why we have to pull it up? Think of it. Think of it this way. Let's say you have this pin from the joystick. It's directly connected to the joystick. Let's say the button is pressed. When the button is pressed, it means this switch connected to the ground, or this switch, the other side of this switch is connected to the ground internally. When you press the button, ground, which is low, which is low or 0 volts, will be the input to the microcontroller when the button is pressed. There will be a connection between ground and the input in the pin number 2. But what happens when the button is released? The button is released. It means the button is floating, is in the air. It's not connected anyway. We'll have an undesired state called floating state. Floating state is neither high nor low. That's undesired state. And floating means there will be fluctuations from high to low, and there won't be any precise value. To avoid this scenario, we need to pull it up. Pull up means when it's not connected to the ground, let's connect it to the VCC or to the 5 volts. There is a way to do it externally using direct connection from this button to the VCC, direct connection, but of course through a resistor like 4.7 kilo ohm resistor or 10 kilo ohm resistor, but we didn't do it externally. There is a way to do it internally. Arduino IDE or Arduino microcontroller allows that. It allows doing such connections internally. Okay, so if you write input underscore pull up, when the button is not pressed or is released, when the button is released, it will by default connect the pin to high. It means you are reading high, you are reading 1 or high when the button is released, and you are reading low when the button is pressed. Let me make a different video on input pull up or pull up resistor. So pull up is done through a resistor, typically 4.7 kilo ohm or 10 kilo ohm. Yeah. To avoid shorting the device when the button is pressed, because the button is pressed, there is a ground. If you connect direct from ground to 5 volts, that's gonna be a short circuit. So to avoid a short circuit, we will put a resistor between VCC and this point, which is the same point of the pin. I think you get it. So because we didn't do it visually here externally, we'll enable this function so that to tell the microcontroller to enable pull-up resistance or pull-up function internally. Okay. This is the this is the button pin. So the type of reading is digital. This is digital. This is analog. So analog, digital. So this is digital read. Digital read. Okay, that is the correction answer number 11. Number 12, I provided provided with this code. This code runs again. So you check the code and you find out the order. It's Python code. So we are familiar with the structure of the code. We can even start here. Answering is on the next page. You can go through the code and check. We all know that the code starts by importing the general structure. We usually start by importing libraries. So section number 2 is section number 1. And what do we do after importing? We'll initialize some sort of things. What are we initializing here? We are initializing Pygame. So that's gonna be section number 2. And we've initialized the code, the Pygame. Is there any other initialization? Let's consider section number 3. Why? Because section number 4 is for closing. We are quitting everything. So this most probably the last one, but let's wait. What does this do? It's kind of initialization. It's opening the serial monitor, and most important, it's initializing or defining the flag running, and that flag initialized here as true. It's the foundation of while loop here. So it's clear this section is section number 3, and this section is section number 4, and of course this section is number 5, last section. Okay, so formalities for answering. We saw that section number 1 becomes section number 4. We saw that section number 2 becomes section number 1. We saw that section number 3 remains section number 3. Section number 4 is the last one. And section number 5 is second section. And why? We read why section number 1 becomes section number 4. Let's start by section number 1. Section 2 becomes section number 1. Why? Because we're importing major libraries are important in this section. Then in the section number 2, Pygame is initialized. And in this section, serial monitor is opened, serial port is opened, and running flag is initialized. Running flag is initialized again. Is initialized as true. Then section number 1 becomes section number 4. Section number 4 is while loop starts and that's where the major program is okay. So this is the closing part. This is the closing part. Okay, that's it. I hope you understood everything. If you have any question, don't hesitate to write a comment on this video. I will immediately answer you. I'll be uploading different videos teaching different things you need to know in this career. This career. So you can subscribe to this channel, and if you like this video, please like it. Please hit the down button. Thank you. See you in the next video.